And hello everyone, we're now live. So again, another quick dev meeting on EHCache 3 to discuss the rapid pace of release we have for the moment, reaching to a soon general availability of EHCache 3.0. And then probably a few discussions around clustered, where we have a number of interesting topics that we may want to play around a bit, at least discuss around. So first of all, RC2 was released a bit more than a week ago, but last week some of us, well actually me, I was on holidays enjoying ski, so we didn't have a meeting. At least I wasn't part of a meeting, and I don't think anybody had a meeting either. So, and so what we did for RC2 is pretty much, so the second release candidate, it's pretty much the same as the first one, like improving on performance and documentation, trying to close all the warts we see on the public API so that we can guarantee a stable public API as of 3.0.0. Which is really important for us because I think it was one of the strong points of EHCache 2x, a very long stability in the API, which helped adoption across its different revisions. But we also decided for one other thing, which is we probably want to keep the flexibility of upgrading and possibly slightly breaking the SPI, so the service programming interface we have internally, to enable us to better adapt to unknown that may come out of clustering development. And we're really here talking about the open source clustering option that we want to release in 3.1.0. And as part of these changes, one visible change, if you've been faithful followers of the milestone and previous RC, is the scope of the default Javadoc that we that you can find on the website, on the ehcache.org website, because it is now limited to just the API. It no longer contains a Javadoc for the SPI. The Javadoc for the SPI is still published. You can find it in the Maven repo. There is an SPI-Javadoc jar, so it's just a different gosh, I'm gonna qualifier. Is that the correct Maven thing we vary on for that? Well, the same thing that for the Javadoc jar, for the sources jar, but you also have an SPI-Javadoc jar, so you can find it there. But we also did upload both the SPI Javadoc and the Javadoc jar on the release page on GitHub, so that you can access both of these. And so, yeah, that's again one point we would be interested in feedback. But the idea is that we want to, for the moment, clearly advertise the user-facing bits and maybe a bit less the bells and whistles we have internally for extending and tweaking EHCache 3 behavior. Because, yeah, we believe it makes less sense as an immediate offering. Any other comments on that RC2 from you guys? And did I forget anything?
Not that I can think of.
Yeah, you were pretty complete.
Cool. RC3, anyone wants to go over that one?
There's a big long list of things we want to get done.
Yeah, and we want to get them for the end of this week, so it's going to be interesting and challenging.
The things that we're prioritizing are the things, obviously, the things that affect the API, which may mean that there's some bugs or fix or behavior fixes. I don't know if you want to call them bugs, that I guess might end up in a dot.
Yep.
But
yeah, so what we're trying to do is look at everything that we deem must be fixed before GA, and making sure that all of these that may still have API impact, because we still found a few of these recently, get fixed in RC3. And then we will be very stringent on what gets inside the GA. So for the moment, we're targeting. I probably should have one of us go and create the. Oh, I think I created the GA milestone. I can't remember if I said
you did, because there were some releasey tasks that we had to put underneath it.
Yeah, I remember that. And so does that one already indicates the date? Because clearly the goal is to have the GA by April 15th. And yeah, it does.
Yes.
So RC3 end of this week, GA by April 15th. Yeah, we've got 13 open issues on RC3, so that's clearly challenging for a few days.
Really? I see 18.
Oh, yeah. I don't know why I did the open minus closed. Yeah, it's 18. It's not because there are 18 open and 5 closed that there are only 13 left. No, it's 18. My bad. Bad at math. I don't know. Confused. Yep. So that's the whole plan. Anything else on that, guys?
Nope.
Nope.
Okay. We jump to the clustering topic.
What did you want to talk about?
The one thing that Ludovic raised recently in discussion, which is about serializers, and the way we currently have implicit contracts in the serializers around constructors.
Oh.
And
yeah.
And the fact that this will probably need an addition for serializer that would be cluster compatible.
Right. Well, so that's not such a big. Well, let me. Sorry. Right. So there's kind of two problems here, and the one you're explicitly mentioning, I actually don't care about. I don't think it's a hard problem to solve. I'm not saying it's not a problem to be solved. It is, but it's not a difficult problem to solve. We know there are a bunch of different ways of doing it. Just pick the right one and do it, and blah. And there's one of them. It's great. The other problem is that and this is why I alluded earlier in conversation offline about transactions. These two, to my mind, both transactions and serializers are situations whereby you have information that you need to store that is sort of in proximity to the cache. It is associated to cache. It's a secondary data structure that's scoped along with the cache.
So to just give context to potential watchers.
I'm sorry.
The way today the EHCache 3.0 disk store works is that the disk store talks to an abstraction that we've called the file-based persistence context, and which just allows it to say, oh, this is the context you get, and inside that context you can do file manipulations. And the context is what? Well, it's a named folder on disk.
Yep.
And that context is provided by the persistence service. And the idea is that the persistence service is capable of providing a context to the store, but it can also provide a context to other services that may require it.
And they'd be within the same space.
And they would be within a same space, where a space is a cache, in the context of a cache. Mm-hmm. And so the way we've done that is that the transaction side of things and the serializers, especially when they have persistent information, do consume a file-based persistence context and are capable of writing extra data
into that
in there.
Yep.
And so, of course, this abstraction works for file-based, but it's not a generic persistence abstraction, which means that when we move to a cluster tier, the cluster tier is also persistent in the context that it outlives the life cycle of the JVM, of the client JVM. But clearly, you can't view it as a file-based, because when you do clustered operation, you can't. So, for example, one thing we do with the serializer, the default serializer we have, is that it saves its state on shutdown, like when the cache is closed. But you can't do that in clustering because you have multiple clients So when you, and for example, the serializer is used to save a mapping which reduces the class serialization information to just a long. But if you do that and wait for the cache to be closed to save it, well, you've broken the whole clustering thing, because then you will have, depending on the clients, you will have maybe different mappings, but also mappings that another client doesn't know anything about.
Mm-hmm.
So you need to have a different life cycle, in the sense that you need the data to be updated live. It may not be the exact same for transaction, but at least for serializer, that's how I see it coming. And that's why the fact that we no longer are on a file-based persistence context, but on a cluster-based persistence context, or something akin to that,
Mm-hmm. Yep.
We will need a different implementation, and we will need then, different interactions.
Yep. So, from my point of view, there's kind of two ways of solving this problem. One way is to introduce, for anything that wants to, so we have to solve this generalized problem of various parts of the EH cache want to be able to store state inside the cluster in association with a cache. Well, they want to store state inside the cluster, and they want to be able to associate it with a cache. It doesn't necessarily mean that the data has to be stored in an area that's technically scoped with the cache. It just means you need to have access to the information to tell which cache it's scoped with, so you can reconstruct the relationship at a later date. That was very contorted. But I think the distinction is important, because one of the ways I'm going to describe that you could do it would rely on such a convoluted operation. So the way that there's kind of, in my head, there's two ways you can conceive of doing this. One is the EH cache. I'm going to use a bunch of terms that might not be that familiar to people watching this. Sorry. The EH cache entity. It's the thing inside Voltron, which is a Terracotta server. The thing inside the Terracotta server that stores the state information of the cache could, in addition, expose APIs, methods, whatever, to store additional state. So in that sense, as a transactions provider or as a serialization provider, you would, or as a foo provider, where foo is something that needs to store state associated with a cache in the server, what you would do is you would have some kind of compile time dependency, or you'd have dependency on the clustering stuff, probably the client module. You would then interact with an API exposed by the client that would allow you to store additional data. That's one way of doing it. And then you naturally get associated. The second thing you can do is actually say, we feed the cache context information to the service, and the service creates its own entity within Voltron in which to store its data. And that way, if you, in essence, the data storage, the interaction API, the data storage API that an extra thing interacts with is Voltron, and therefore the dependency is not on the cluster, the client's clustering code; it's on Voltron itself. And it also opens up the possibility that if you want to store information that's proximal or that's associated with a cache, it doesn't have to be stored in Voltron. It can be stored elsewhere. It also makes situations whereby, for example, you have a serializer that maybe wants to share its state, not just like transactions want to store state that's associated with caches. We know that. Serializers want to store, can store state in a large number of different ways. It could store the state information associated with the cache. It could associate it with the cache manager. It could store it in some kind of global static location. It doesn't actually matter what it is, and so by decoupling this and saying, well, you don't have to go through the clustering service stuff, you could actually talk to some. I don't know, if you're the compact Java serialization provider, then you could talk to the singleton compact Java serialization server-side entity thing, where it stores these compressed type mappings or object stream class serializer things in some blanket across every EH cache instance you hosted in that Voltron server, all cache managers, all caches, blah, 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 single mapping. Does that make sense? And do we think there's any value in that second description, or do we think that it should just be exposed? The thing that makes me kind of lean towards that is none of its advantages. It's actually the fact that that it keeps the EH cache entity we have now is really nice. Then it's not the EH cache entity; it's just the store entity. All it's doing, it has a single responsibility. It stores store state. Key value pairs. It doesn't store anything else. That API is really simple. It can be evolved separately. It's bound to one particular module. It's not bound to anything else. And then the transactions code can then have its own Voltron dependency or whatever. Does that make? Did what I say make sense, or does it just sound like I'm?
What kind of issues would you run into with ensuring that the information is up to date with respect to cache content?
Well, it has to. Well, I guess the argument here is it has to be up to date, or you have to know that it's not. So, if, for example, you use, like, you had a separate cluster, right, that you used to store. I mean, this is insane, but you could do it. You could have because right now, what we'd probably be looking at is that the transaction stuff and the serialization stuff, and anything that wanted to store secondary state, would probably retrieve the clustering service and effectively get its it'd probably go through the same connection. It would probably just, like, the clustering service would effectively expose a way to get the Voltron connection and create your own entities of it. But the only thing that's actually important is that it's possible to get something that looks like it's in sync, i.e. you don't actually have to have it in sync, you just need to know that it's not. So if you ran two clusters, for example, and you put a mapping, you're using the serialization thing, and then you wrote the class descriptor into the centralized data structure, and then some other client went to read it, and it said, oh, I don't have a mapping for that. But I can wait for it to appear, because it should appear. Because you know that you expect it.
Well, couldn't you run the situation, the chance then of having a client who's written something to the cache crash before it actually gets the serializer state written out to the
well, as long as you write the serializer state and you make sure it's durable before you write the cache state, then you're safe.
Yeah.
But the thing is, everything you described there is true even in a non-split model, even where you allow the entity, you make the entity itself, the cache storage entity, store this secondary data. Unless you actually implement two-phase commit and you actually, like, do it transactionally or something, you can still run into problems with it tearing. But as long as you do things in the right order, the tearing is not a non-issue, I think. From my point of view, it seems kind of nice to model this as an entity has from a solid principles SRP point of view. It's kind of nice that the entity we're working on now's job is to store key value pairs. We have a separate entity to store the serialization look-aside structures that we could, at our discretion, either make a single instance per cache manager, or a single instance per cache, or whatever, right? Or a static instance across multiple cache managers. Does that make sense?
Mm-hmm.
I don't know. It was just an idea that kind of struck me as it might be. It's a nice separation of concerns, and I don't think it's too hard to implement. Oh no, that's not true. I don't think it's any harder than doing it any other way.
Makes sense.
And it also minimizes I think it kind of cleans up the dependency model too. It's a little more sketchy in the case of transactions, because there the information is much more sort of tightly bound to being cache associated, whereas in the serialization, obviously, as we discussed, it's not.
Not exactly. You can view the transactional data roughly comparable to the serializer data. It must be written before the modifications to the,
Oh no,
to the cache
I
are
meant
visible.
I meant in the scoping sense, right? The information it's storing is explicitly can't be shared between caches. It doesn't make sense. It is related to the cache. It's to do with transaction states, right?
Yeah, but again, you could also have, like for the serializers, a grand pool shared across all cache managers. It's fine because
as long as you can,
as long as there are unique identifiers, it's fine.
Yeah. So the only thing these secondary structures need to know is some kind of persistent identifier, and the identifier can be the alias. It's what we're using for other things. And actually, I guess it's not actually. In the case of transactions, it's not actually. Here's the thing: in the case of transactions, it's not correct to tie it to the cache. It's correct to tie it to the XA resource identifier. Right?
Good point.
That's the correct mapping. And since we've actually technically decoupled those in transactions for the moment, whether we wanted to or not, you even need to know that it's just XA resource identifier. So then it just means extra entities. And so the only thing that the clustering service really needs to share is the connection, so that you can get references to other entities through it. You look puzzled, Louis, or maybe you don't. Maybe it's only seeing your thumbnail, so.
No.
At least for a secondary question, if you want to entertain it. Makes me wonder if the fact that you want to retrieve the connection so that you can create entities and get new entity fetch new entity references, makes you wonder if you should decouple the parts of the current clustering code that deal with interactions with the hcache entity from the part that creates the cluster connection. Which then leads back to the question that PM had asked us, which was, what if I want to share the same connection between multiple cache managers?
Yeah, but I think that the sharing of a connection is something that we can work on at a later stage. Right,
but it feels like the separation that you would need to do that would be the same as might be a logical separation if you want to provide the.
No, because it would be, we could still do a logical separation inside a cache manager, which is different than having a separation outside of the cache manager.
So, let me be clear. We would separate these two services because from a single responsibility principle, you should have the same service exposing this really high level, please let me interact with the store API, as well as, and here's the connection I'm using because you want to use it for something else. You should split that.
But in today's world, unless you willingly do not implement start and stop on a service because you expect to lifecycle it yourself outside of the cache manager, we have nothing to offer for such a construct. And I don't think I want that to be the final answer. Like, yes, use that clustering connection service which blatantly ignores start and stop because at the moment you construct it, it opens the connection and it will close it only when it gets garbage collected.
Sure. Yeah, I'm not. Yeah. So I think we should split those services
to mix the two. But I think in everything you proposed, yes, it's one way of viewing the problem. The other way would be to say, can we come up with a single data structure abstraction that both XA and serializer could use? We initially start with that.
What's the advantage of a single abstraction?
Simpler.
Less code to write.
Less, yeah.
But if that's the case, you can have. See, here's the thing for me. If you want to say single data structure, well, fine, we can come up with that, and they can share that code as a common dependency. But it doesn't mean it has to be folded into the hcache entity. So if they both want to create, so if you find, okay, let's say you decided the common abstraction is a stack. It's not a stack. I know. I'm trying to pick one that's essentially
like if you use a cluster map.
We can create a Voltron resident stack entity type, and they can both instantiate them and use the same code.
Why would they share the same and stuff like that? Yeah, okay, I see. Indeed, it probably the model. Actually, the model would just be closer to what we had in the previous line, where the 4x clustered code like just offers you a number of clustered data structure, and you
already have
do
a cluster map.
Yeah, and you would do what you need with these cluster data structure.
And there's some great advantages here, because I think that the caching model is way simpler, for example. Like in the case of, I think that the entity with the common code they would share would likely be the actual clustered data structure, but they would have different caching code. Because, for example, actually it might be true in both cases, Ludovic would know on this, but for the serialization, once you've cached a given representations mapping locally, that mapping cannot change.
No.
They're canonicalizing mappings, and it never gets cleared. So the caching model is really simple. So whereas for XA maybe it's more complicated, although I think maybe it's not, because the XIDs never get recycled.
Yeah.
You just want to. The only thing with the transactions is you want to be able to flush them when you're running out of memory, or when somebody does remove. So there are remove operations. But anyway.
Okay. Cool.
That seems like a spitballed idea. I mean, I don't need to. The other nice thing about this is it means temporarily we don't have to use a stateful serializer and clustered while we're getting things working.
No. We can.
It can be easily added at a later date.
Yes.
And we don't have to support transactions immediately, and it can be easily added at a later date. And neither of those additions require modification of the actual underlying store key value code.
Yeah. Correct.
That's the good news.
And we always like delaying doing any work until later.
Well, we're good developers.
Yeah, lazy.
Just a touch of laziness.
Just a touch?
Just a touch.
Hey guys, remember, I'm also half a manager, so I delegate some of my laziness to you.
To other people. That's why I'm doing. That's why we're so lazy. It's because Louis is delegating laziness to us.
Oh, God. One of the major... I'm just going to jump back to RCs and GA.
Mm-hmm.
So we had a discussion earlier this week about getting rid of the persistence cache manager to maintenance.
Oh yeah.
And so that's issue 929 on GitHub. And the way I phrased it is, so in the context of a disk persistent cache, this to maintenance destroy is kind of not really needed, because when you initialize a cache manager, given that the open source disk store does not give you any strong guarantee on durability, if it finds files and the index and the data file are properly in sync, it will load them. If it doesn't find files, or if it finds them out of sync, it will delete and recreate. And so it's implied that the disk store works in an auto-create mode.
Yep.
You can't really say only initialize my cache if you find data files. That doesn't exist. We want to have something like that for clustered. We want to have a system where you say, if you don't find, don't start.
Mm-hmm.
So we thought at the time, but the to maintenance with a create and a destroy on it makes sense, because then you can do atomic destruction, recreation, and things like that with exclusive maintenance mode, etc., etc.
Yep.
But on further thinking, we realized that, first of all, for developer convenience and for scale continuum, we will have a kind of auto-create mode for clustering. The final form is not yet decided, but if you look at the clustering code as it exists today, it shows that it's there. Mm-hmm. But we also know that we will want to have some different tool to create cache managers and caches, like the clustered entities that represent these, which would be different than plain Java code using the EHCache APIs.
Mm-hmm.
And so in that context, the reason for filing that issue is that we realize that what the toMaintenance destroy create enables, we're actually saying that we would rather have people doing with a completely different set of code. Code that lives in a cluster setup environment rather than code that lives in your application startup. And so what we envision is that the production deployment of EHCache clustered should be my cache manager and caches are configured to use what's created in the cluster with more or less checking of what you have is what you expect. But we don't expect the application, like the first node of the application connecting to the cluster, to create anything. It should find everything it needs already created. And so in that sense, we're saying, okay, let's get rid of that toMaintenance method. And the second reason is that if we get rid of it today, one thing we need to add is a persistent cache manager destroy, which still enables to clear all the disk data that the persistent, like a disk store and a persistent cache manager could have. But it does not prevent us in the future to do a compatible addition of reintroducing a toMaintenance to enable a destroy create if we deem it makes sense and if users show us it makes sense. And so I guess that's probably going to be, again, it's a big API-facing change, but I believe we do it for the best. And again, it kind of links to the laziness.
It is and it isn't. It is and it isn't. Because the fact is, I doubt anyone's using those methods at the moment. Even if we'd had even if like everybody was using 2 instantly migrate to 3, I think very few people would use those methods. Because the fact is, in 2, they didn't exist. People subsisted without this method, the ability to do this thing forever and ever and ever, and it didn't bother them. So I don't actually see it as a big API change.
No, but it's something we've always advertised that we will have much clearer life cycle and things like that and stuff. And from the initial getting started on the disk store, we would explain that if you want to destroy everything, you have to go to maintenance, mark destroy, then leave maintenance, reinitialize and stuff like that. So
right, but the key aspects of that toMaintenance are still preserved. You still have to enter maintenance mode to destroy.
Yes, yeah. So we're changing the API. We're not changing the underlying lifecycle guarantees that we want to give.
So if other people have, if in clustered somebody else has that cache fetched,
so to be clear, yeah, exactly. If in the past it was very explicit that when you would call to maintenance, you would fail to go to maintenance if you were not the only one. If you would call destroy on a persistent cache manager which is clustered, you would still fail to destroy anything if you could not acquire the maintenance. So the destroy operation will have the same exception that the toMaintenance.
Yeah, and the same should be true for. Well, the same is true for
create
for unclustered. You won't be able. If you call destroy and the cache manager is initialized. No, you can't do that. Some other thread in your system might be accessing caches.
Yeah, you need to close it first.
You need to close the cache manager, then you can destroy the cache manager.
Yep. Okay.
Or it needs not to have been initialized, obviously.
Yeah, so it truly is an API change, but the lifecycle.
We keep the lifecycle the same. Yes.
Yep. And like I said, I doubt very few people are using this method, so I don't think it's a. Yep. It should not impact too many people.
Yep. The only thing we no longer enable from the API point of view is the atomic destroy recreate.
Right.
That made sense only in clustered because it's
And actually, I don't know. Can a database do that? Can you drop a table and then atomically create a new one in its place?
Some databases used to support that, but most don't.
Because the anticipation is if you're doing that kind of thing, you're going to enforce the atomicity yourself by making sure that there's only one and only one thing interacting with the system. So I don't think it's unheard of or unreasonable for us to say the same thing.
No, and as discussed, while the creation of the clustered entities versus the access of the clustered entities can be a bit seen as DDL versus query language in databases, we also know that comparison falls short in places because it's not exactly the same.
No.
Okay. Anything else?
Do we want to bring up tiering with clustering? Or should we defer that to a later discussion?
What did you want to know? What did you want to talk about?
Is it the whole discussion about the store API and stuff like that?
Basically how we want to structure tiers in a clustered environment.
It's the same.
Yeah, we want cluster to be able to either work standalone or as the authority.
I would rephrase that. We want to be able to work clustered. You want to be able to configure clustered as the only resource in the system if you want, although I think the use cases for that are extremely narrow, possibly nothing. And you also want to be able to configure it with other local resources. The reason I don't want to say authority is because that's the terms associated with the current store SPI, and it is still not clear to me how that's going to be achieved. I.e., will clustering use the same store API?
Okay, but so that's one of the reasons. So clearly, so that's an open conversations. I mean, it can have a S and probably multiple S's. And that's one of the main reasons we did these changes of really splitting the API and the SPI stuff to make sure that to indicate better what we allow ourselves to change. So if you look today in EHCache code structure, you'll find three things. And I'm just gonna talk about the final artifact you see as a user. You'll find stuff which is in org EHCache. And submodules, well, all modules all packages are subpackages of these. But like org EHCache, then you've got config, event, exceptions, expiry, SPI, stuff like that. These are all the public API things we will never change. Then you will find larger sub-packages like core, impl, XML, transactions, GSR 107. And these are what we would call the SPI. And then inside of these, you will even find internal packages. And these are what we consider private API. If we were today releasing under JDK 9, we would have a binary which declares these modules are which does not expose these modules. It would just expose the API and SPI ones. And the thing we're saying is that the SPI, we want to keep it on a less strict compatibility rules than the API one. And so we would like to say that API will never be broken, so will only be extended in compatible ways from dot version to dot version, while the SPI we allow to break it, but we will of course maintain SPI compatibility in bug fixes release. So 3.1.0 will have the same API, may have a different SPI for a number of places, but 3.0.2 will have the same API and SPI as 3.0.0, and same between 3.1.0 and 3.1.5. So that's
I suppose we might revisit that rule later on.
And
the idea is stricter with the SPI.
The idea is, of course, that once we've got clustered out and we can see that clustering works and does everything we want the way we expect it to do, then we can probably freeze the SPI as well, because we'll have most of the major features that make up EHCache 3 released. So it might be a temporary rule between 3.0 and 3.1. That's true.
One of the things I wonder about as well on the SPI front, which would be a more serious SPI change, no one's talked about this yet, is will the cache loader writer interface stay the same for cache loader writers that are clustered?
Yeah, possible. We'll see.
That's one of the things that's really up in the air because we know that feature is going to be complicated. At least would be a gentle way of putting it.
Yeah.
Interesting.
Yes.
Certainly going to be interesting. Yes.
Okay. Anything else? Well, then that's it. Thanks for your times, everyone. Happy watching. Hope you enjoyed the watch. And see you soon with a released version of EHCache 3.
Oh, are we doing a meeting next week?
We may, but it probably will happen at a different time. How's that for an answer? Yeah.
It's a good answer.
Bye, thanks.
That's it.
Bye.